Good morning, students. Am I audible, visible? Let me know through the chat box. Write in the chat box, am I audible? Okay. Am I audible? Are you getting my voice? Okay. So today we'll start a new topic. That is continuity. Okay. Write down. Write down a real valued function. Y is equal to f of x is said to be continuous a real valued function y is equal to f of x is said to be continuous at x is equal to a if the following conditions are satisfied. The first condition is limit extending towards a plus f of x exists. Limit extending towards a plus f of x is your right hand limit. So RHL exists. Second one, limit extending towards a minus f of x exists. That is LHL exists. Third one, functional value at x is equal to a exists. F of a exists. And the fourth condition is LHL is equal to RHL is equal to value of the function. Limit extending towards a plus f of x equals limit extending towards a minus f of x equals f of a. Okay. If all the four conditions are satisfied by a given function at x is equal to a, then you can say that the function is continuous at x is equal to a. If at least one of the above condition fails, then the function is said to be discontinuous at x is equal to a. Note it down. If at least one of the above condition fails, then the function is discontinuous at x is equal to a. Okay, to check the continuity of the function at a given point, we have to find out the left hand limit, right hand limit, and the value of the function. If left hand limit exists, right hand limit exists, value of the function exists, and all are equal at x is equal to a, then you can say that the function is continuous at x is equal to a. Otherwise, the function is discontinuous at x is equal to a. Okay. Let's come to solve a couple of questions. Question number 1. Discuss the continuity of the function. Discuss the continuity of the function f of x equals mod x upon x if x not equal to 0, 0 if x is equal to 0 at x is equal to 0. Okay. Discuss the continuity of the function f of x is equal to mod x by x if x not equal to 0, 0 if x is equal to 0 at x is equal to 0. This function is called signum function. So to check the continuity, we have to calculate the left hand limit at x is equal to 0, right hand limit at x is equal to 0, and value of the function at x is equal to 0. Value of the function at x is equal to 0 is given, that is equal to 0. So come to the solution. F of 0 is equal to 0, it is given. Then find the left hand limit, LHL. Left hand limit extending towards 0 minus f of x. When x tending to 0 from the left hand side, x is not equal to 0. Suppose this is the number line. This is 0. X is approaching to 0. Previous page. Okay. Complete. Should I move forward? Write in the chat box. Have you written down the contents of this page? Okay. So suppose x is approaching to 0 from the left hand side. X is approaching to 0 from the left hand side. That means x is very, very close to 0 from the left hand side and x is not equal to 0. When x is not equal to 0, the function is defined as mod x upon x. So this is equal to limit extending towards 0 minus. 0 minus means not 0 minus means x is approaching to 0 from the left hand side. Mod x upon x. In previous class, I told you how to find the left hand limit. So this is equal to limit extending towards 0. 0 minus h mod upon 0 minus h. This is equal to limit extending towards 0. Mod of minus h is h upon minus h. H upon minus h is minus 1. So left hand limit of the function is minus 1. Okay. Now calculate the right hand limit. Limit extending towards 0 plus f of x. This is equal to limit extending towards 0 plus mod x upon x. This is equal to limit extending towards 0, 0 plus h mod upon 0 plus h. This is equal to limit extending towards 0, h upon h, which is equal to 1. So for this function, left hand limit is -1, right hand limit is 1, and value of the function is 0. So LHL is not equal to RHL is not equal to value of the function. Hence we can say that the function is discontinuous at x is equal to 0. So note it down. Function is discontinuous. Function is discontinuous at x is equal to 0. Is it clear to you? Let me know through the chat box. Write in the chat box whether it is clear to you. Quick, note it down. Okay, write on the next question. Should I move forward? Should I go to the next page? Write down the second question. Discuss the continuity of the function. Discuss the continuity of the function f of x equals 3x plus 11 bracket value at x is equal to minus 11 by 3, where bracket is the greatest integer function, GIF, where bracket is the greatest integer function. We have to discuss the continuity of the function f of x is equal to 3x plus 11 bracket value at x is equal to minus 11 by 3. Okay, come to the solution. First of all, we have to find out the value of the function at the given point. The given point is minus 11 by 3. F of minus 11 by 3 equals 3 into minus 11 by 3 plus 11 greatest integral value. This is equal to minus 11 plus 11. This is equal to greatest integral value of 0. All of you know greatest integral value of an integer is that integer only. So we find the functional value of the function is 0. Then come to left hand limit, LHL. Limit extending towards 0 minus 3x plus 11 bracket value. Sorry. Limit extending towards minus 11 by 3 minus, this is equal to limit extending towards 0, 3 into minus 11 by 3 minus h plus 11 bracket. This is equal to limit extending towards 0, minus 11 minus 3h plus 11, minus 11 plus 11 cancels. This is equal to limit extending towards 0, bracket value of minus 3h, right? When h is approaching to 0, that means h is very, very small. Let us suppose h is equal to 0.001. 0.001. Then 3h will be 0.003 minus 3h will be minus 0.003, and the greatest integral value of this quantity is equal to -1. All of you know that if x lies in the interval -1 to 0, if a quantity lies in the interval -1 to 0, then its greatest integral value is -1. So left hand limit of the function is -1. Okay. Then come to right hand limit, RHL. Limit extending towards -11/3 plus 3x plus 11 bracket value. This is equal to limit extending towards 0, 3 into -11/3 plus h plus 11 bracket value. This is equal to limit extending towards 0, -11 plus 3h plus 11. This is equal to limit extending towards 0, 3h bracket value. Since h is very small and positive, so 3h is also very small and positive. So 3h lies in the interval 0 to 1. So greatest integral value of a quantity which lies in the interval 0 to 1 is 0. Okay. So for this function, left hand limit is -1, right hand limit is 0. Value of the function is 0. So left hand limit is not equal to right hand limit. So limit of the function doesn't exist. Hence the function is discontinuous. Right hand the function is discontinuous at x is equal to -11/3. Did you understand, guys? Sir, please explain the last line again. Jagdish, Revensa. Okay. Jagdish, should I explain the last line? Okay. Okay. So I'm writing the last line again in the another page. You just note it down. I'll use another page to explain you the last line. That is the right hand limit of the function. Okay. Right hand limit, RHL. Right hand limit, extending towards -11/3 plus. First of all, we have to know what is the -11/3 plus. Suppose this is the number line. This is the point -11/3. -11/3 plus means x is approaching to -11/3 from the right hand side. That means x is very close to -11/3 and it is just greater than -11/3. So we can take x is equal to -11/3 plus h, where h is a very small positive number. Jagdish, got it? 3x plus 11 bracket. So this can be written as limit extending towards 0, bracket value of 3 into -11/3 plus h plus of 11 bracket value. This is equal to limit extending towards 0. 3 into -11/3 is -11 plus 3 into h 3h plus of 11 plus 11 minus 11 cancels. Limit extending towards 0. Bracket value of 3h. What is h? H is a very small positive number. Let h is equal to 0.001. So 3h will be 0.003. So bracket greatest integral value of 0.003 will be 0. So if a value lies in the interval 0 to 1, including 0, excluding 1, then its greatest integral value is 0. So right hand limit of the function is 0. Jagdish, did you understand? Let me write in the chat box. Okay, Surajit, send Samantara sir previous page. Okay, previous page. Okay, let's move forward for the next question. Question number 3. If f of x equals e raised to the power 1 by x minus 1 upon e raised to the power x plus 1, if x not equal to 0, 0 if x is equal to 0, then discuss the continuity of the function. Then discuss the continuity of the function discuss the continuity of the function at x is equal to 0. Okay. Discuss the continuity of the function at x is equal to 0. So guys, come to the solution. The functional value of the function is given, that is 0. F of 0 is equal to 0, right? Now we have to calculate both left hand limit and right hand limit of the function at x is equal to 0. Let us calculate the left hand limit first. LHL, that is limit extending towards 0 minus, that is x approaching to 0 from the left hand side. That means x is taking very, very small negative number. Okay. So limit extending to 0 minus f of x will be e to raise to the power 1 by x minus 1 upon e to raise to the power 1 by x plus 1. Okay. If you don't know how to calculate the left hand limit and right hand limit of a function, then it will be very difficult for you to understand. Okay. Already I have discussed when I was taking the class of limit. So this is equal to limit extending towards 0, e raised to the power 1 upon 0 minus h minus 1 upon e raised to the power 1 upon 0 minus h plus 1. This is equal to limit extending towards 0, e raised to the power minus 1 by h minus 1 upon e raised to the power minus 1 by h plus 1. Okay. This is the decision stage. This is the analysis stage. Okay. Jagdish, try to focus on it. So h is approaching to 0. So if h is very, very small, then 1 by h is very, very large. 1 by h tends to infinity. Minus 1 by h tends to minus infinity. So e raised to the power minus 1 by h approaches to e raised to the power in minus infinity. That approaches to 1 upon e raised to the power infinity. You know, the value of e is equal to 2.71828. Okay. So e to the power infinity is infinity. It is a very, very large quantity. 1 upon very, very large quantity is 0. So when h approaching to 0, e raised to the power minus 1 upon h approaching to 0. So this limit will be 0 minus 1 upon 0 plus 1. This is equal to minus 1. So guys, is it clear to you? Jagdish? Write in the chat box, is it clear to you? Did you understand? Hello. Okay. Then right hand limit, RHL, limit extending towards 0 plus e raised to the power 1 by x minus 1 upon e raised to the power 1 by x plus 1. When extending to 0 plus 1 by x approaches to infinity, e raised to the power infinity approaches to infinity. Infinity minus 1 upon infinity plus 1 is infinity upon infinity. So directly we can't calculate the limit. We have to manipulate. Okay. If the limit takes any indeterminate form, either 0 by 0 or infinity by infinity or 0 into infinity, any indeterminate form, there are 7 indeterminate forms. Then we have to manipulate the function to get the limit of the function. So what we'll do here, we'll divide both numerator and denominator by e raised to the power 1 by x. Divide both numerator and the denominator by e raised to the power 1 by x. That will give you limit extending towards 0 plus 1 upon e raised to the power minus 1 by x upon 1 plus e raised to the power 1 by x. Okay. When x is approaching to 0 plus, x is very, very small. 1 upon x is very, very large. That is infinity. So minus 1 upon x approaches to minus infinity. E raised to the power minus 1 upon x approaches to e raised to the power minus infinity. E raised to the power minus infinity approaching to 0. So this is equal to 1 minus 0 upon 1 plus 0. That is 1 by 1 is equal to 1. So here value of the function is 0. Left hand limit is minus 1. Right hand limit is equal to 1. So value of the function is not equal to left hand limit, is not equal to right hand limit. Hence we can say that the function is discontinuous at x is equal to 0. This function is discontinuous at x is equal to 0. This function is discontinuous at x is equal to 0. So guys, I hope it is clear to you. So write in the chat box. Okay. So quickly note it down, guys. I'll go for to the next page and discuss next question. So write down the next question. I think it is question number 4. So far we have discussed 3 questions. Question number 4. Discuss the continuity of the function. Discuss the continuity of the function f of x is equal to bracket of x square, bracket means greatest integral value, minus 1 upon x square minus 1, if x square not equal to 1, 1, if x square is equal to 1, at x square is equal to 1, at x square is equal to 1. Okay. Discuss the continuity of the function f of x is equal to x square bracket minus 1 upon x square minus 1 if x square not equal to 1, 1 if x square is equal to 1 at x is equal to 1. So guys, take 2 minutes of time and approach this question. Okay. Yes. Asrin, you are present today, but you are not responding. Okay. So what is the value of the function f of 1? So when x square is equal to 1, then x is equal to 1. So x square is equal to 1 means x is equal to plus or minus 1. When x is equal to plus or minus 1, f of x is equal to 1. So f of 1 is equal to 1. All right. Then we have to find out both left hand limit and right hand limit. Left hand limit and right hand limit. LHL. Limit extending towards 1 minus f of x. This is equal to limit extending towards 1 minus x square bracket minus 1 upon x square minus 1. This is equal to limit extending towards 0, 1 minus h whole square bracket minus 1 upon 1 minus h whole square minus 1. This is equal to limit extending towards 0, 1 plus h square minus 2h bracket minus 1 upon 1 minus h whole square minus 1. So, x plus I bracket value is equal to bracket x plus I, where I is an integer. So this is equal to limit extending towards 0, 1 plus bracket of x square minus 2h, okay, minus 1 upon 1 minus h whole square minus 1, right? Plus 1 minus 1 cancels. So inside the bracket, the expression is h square minus 2h, where h is a very, very small. If h is very, very small, if a quantity is very, very small, higher power of that quantity will give you the lower value. If you take h is equal to 0.5, then what will be h square? H square is equal to 0.025. So which one is greater? H is greater than h square. Since h is greater than h square, so h square minus 2h is a negative quantity and very, very small. So its bracket value will be -1. Its bracket value will be -1, and this value approaches to 0. So this limit doesn't exist. The limiting value, we can say infinity, or limit doesn't exist. Did you understand? Write in the chat box. LHL is clear. Left hand limit doesn't exist. Sir, please again. Okay. H is extending to 1 minus f of x, extending to 1 minus x square bracket minus 1 upon x square minus 1. Extending to 1 minus means x is not equal to 1. If x is not equal to 1, then x square not equal to 1. X square not equal to 1 means function is x square bracket minus 1 upon x square minus 1. X square bracket minus 1 upon x square minus 1. So x is equal x approaching to 1 from the left hand side. This is 1. Okay, x approaching to 1 from the left hand side. So x will take the value which is very, very close to 1 but less than 1. That will be 1 minus h. So for this limit, you can write limit extending towards 0, 1 minus h whole square bracket minus 1 upon 1 minus h whole square minus 1. So 1 minus h whole square is 1 plus h square minus 2h bracket minus 1 upon 1 minus h whole square minus 1. Okay, and here x plus I bracket value is equal to bracket x plus I. So 1 plus h square minus 2h bracket is equal to 1 plus bracket value of h square minus 2h minus 1 divided by 1 minus h whole square minus 1. So this is the decision stage. This is the analysis stage. When h is very, very small, h square is less than h. If h square is less than h, h square is less than 2h, h square less than 2h, and h square minus 2h is less than 0. H square minus 2h is less than 0 and very, very small. That means this quantity lies between -1 and 0. If this quantity lies between -1 and 0, its greatest integral value will be -1. So -1, when h approaching to 0, the denominator approaching to 0, numerator approaching to -1, denominator approaching to numerator approaching to -1, denominator approaching to 0. So total value approaching to negative infinity. Total value approaches to minus infinity. So we can say that the limit of the function doesn't exist. Huh? The normal oh. Okay, guys. Surajit, is it clear? Hello. Nasrin, is it clear? So similarly, you find the right hand limit of the function. With a similar analysis, you can be able to find the right hand limit of the function. शिबानी उर्मल नो सर क्यों क्या हुआ कहाँ से दिक्कत आया बोलो राइट इन द चैट where are you face the difficulty शिबानी where you face the difficulty sir please 1 second okay please 1 second means I will take another page so just a minute guys okay 1 second limit extending to 1 minus limit extending to 1 minus f of x this is equal to limit extending to 1 minus x square bracket minus 1 RHL Shruti just wait let me discuss x square minus 1 upon x square minus 1 this is equal to limit extending towards 0 1 minus h whole square minus 1 bracket upon 1 minus h whole square minus 1 okay now apply a minus b whole square formula this is equal to limit extending towards 0 1 plus h square minus 2h bracket minus 1 upon 1 minus h whole square minus 1 okay so consider this one as a x plus 1 bracket value is bracket x plus 1 bracket value is bracket x plus 1 this is equal to limit extending towards 0 1 plus bracket value of h square minus 2h minus 1 upon 1 minus h whole square minus 1 here plus 1 minus 1 cancels when h is approaching to 0 that is 0 plus when h is a very small positive number h square is less than 2h h square minus 2h is a negative quantity which lies in the interval -1 to 0 its greatest integral value will be -1 it is -1 and the denominator approaching to 0 total value approaches to negative infinity so limit of the function doesn't exist okay I hope it is clear to you Let me calculate the right hand limit of the function at x is equal to 1. Limit extending to 1 plus f of x, right? This is equal to limit extending to 1 plus x square bracket minus 1 upon x square minus 1. This is equal to limit extending towards 0, 1 plus h square minus 2h, sorry, plus 2h, bracket minus 1 upon 1 plus h square minus 1. So this is equal to limit extending towards 0, 1 plus bracket value of h square plus 2h minus 1 upon 1 plus h whole square minus 1. Plus 1 minus 1 cancels. Okay. Now the analysis stage. Shruti, you see h approaching to 0. So h square is also approaching 0. 2h approaching 0. H square plus 2h approaches to 0. This value lies between 0 to 1. And its bracket value is absolute 0. Its bracket value is absolute 0. And the denominator is approaching the 0. Absolute 0 by approaching to 0. That means 0, suppose 0 by 0.001. Shruti, what will be this value? 0 by 0.001. 0 by 0.001 will be 0. So note it down. Absolute 0 upon approaching 0 is 0, not indeterminate form. Did you understand? Absolute 0 by approaching 0 is 0. RHL न काढिले भी चलिबो, हाँ चलिबो। बढ़िया तो लिखुछ। होनी तो आमी डायरेक्ट द फंक्शन इज डिसकंटिन्यूअस लिखि परिबानी की लिखि परिबा? Is it clear to you? Vivo V2443. What is your name? Vivo? Your device name is Vivo, but your name is not Vivo. Why don't you write your name? So guys, first part of the continuity is over. Now we'll start the second type of questions asked in JEE Mains and JEE Advanced. So write down type 2. Question type 2. ठीक है, तो टाइप 2 to find the value of the unknown parameter to find the value of the unknown parameter or unknown quantity involved in the function involved in the given function if the function is continuous at the given point. If the function is continuous at the given point. First, write down the heading. Okay. To find the value of the unknown parameter or unknown quantity involved in the given function if the function is continuous at the given point. Okay. So write down the question. Find the value of A, B, C. Find the value of A, B, C. Nasrin, I think you are absent in my last class. Find the value of, when I was taking the class of functions, find the value of A, B, C if f of x is equal to sine of a plus 1 x plus sine x upon x if x less than 0, c if x equal to 0, under root x plus bx square minus under root x upon bx to the power 3 by 2 if x greater than 0. Okay. The function is defined in three different ways. For negative values of x, the function is sine a plus 1 into x plus sine x by x. For x is equal to 0, the value of the function is 0. For x greater than 0, the function is under root x plus bx square minus under root x upon bx to the power 3 by 2. If this function is continuous, if f of x is continuous at x is equal to 0, if this function is continuous at x is equal to 0, then find the value of a, b, and c. If this function is continuous at x is equal to 0, then then find the value of a, b, and c. An important thing I want to share with you. So I think college schools are closed now. So why don't you attend the second session? That means from 9:15 to 10:45. Most of the students are absent. In the first session, what is the attendance? Attendance is 38. You'll see in the second session, attendance will be 15 or 20. Why you are not attending the second session? And today's second session will be very amazing. I'll discuss all the JEE main questions, previous year questions. Okay. So let me discuss this question. If you are not going to college, school, then you should attend the second session. Today's second session will be very amazing. So okay. So have you written down the question? Right? We will note down the question on your copy. I'll use the next page. So directly here you can write the value of the function is given. That is f of 0 is equal to c. F of 0 is equal to c. Right? Now we have to calculate the left hand limit and right hand limit. Left hand limit will be calculated at this function, and right hand limit will be calculated at this function. Okay. So I am using the next page. Write down the left hand limit. Left hand limit or LHL. Limit extending towards 0 from the left hand side. That is limit extending to 0 minus. You know, sine function is a continuous function. No need to express 0 minus h or 0 plus h. Directly calculate the limit. Okay. Limit extending to 0 minus sine of a plus 1 into x plus of sine x divided by x. Now separate this limit into sum of two limits. This is equal to limit extending to 0 minus Sine of a plus 1x upon x plus limit extending towards 0 minus sine function is continuous. So hence 0 minus or 0 plus, it won't affect the question. Directly you can calculate the limit, okay? All of you know limit extending towards 0. This is a standard formula. Limit extending towards 0, sine x upon x is 1. Limit extending towards 0, sine x upon x is 1. So this is equal to limit extending towards 0 minus sine of a plus 1 into x upon a plus 1 into x into a plus 1 plus limit extending towards 0 minus sine x upon x. This is equal to limit extending to 0, sine x upon x is 1. 1 into a plus 1 plus of 1. This is equal to a plus 1 plus 1. That is a plus 2. So left hand limit of the function is a plus 2. Is it clear? Left hand limit of the function. Then come to right hand limit. RHL. Limit extending to 0 plus under root x plus bx square minus under root x upon bx raised to the power 3 by 2. Now you can take x as common from the, sir, please show previous page. Okay. This page. Yes, sir, done. Okay. So now you can take x as common. This is equal to limit extending towards 0, root x into under root 1 plus bx minus 1 upon bx to the power 3 by 2 is b root x into x. Root x cancels. Okay. So this is equal to limit extending towards 0 under root 1 plus bx minus 1 upon bx. Already I have told you, shoot outside, rationalize. So this is equal to limit extending towards 0 under root 1 plus bx minus 1 into under root 1 plus bx plus 1 upon bx. We have multiplied this factor to nullify. We have divided with the same factor, that is 1 plus bx plus of 1, right? So a minus b into a plus b, that is a square minus b square. This is equal to limit extending towards 0, 1 plus bx minus 1 upon bx into under root 1 plus bx plus of 1 plus 1 minus 1 cancels, bx cancels. Now directly substitute x is equal to 0 in the function. That will give you 1 by root over of 1 plus 1, that is 1 by 1 plus 1, that is equal to 1 by 2. So right hand limit is 1 by 2, functional value is c, left hand limit is a plus 1. Since the given function is continuous at the given point, it is given. So right hand limit should be equal to value of the function. Value of the function is c, right hand limit is equal to 1 by 2. So c is equal to 1 by 2. Since the function is continuous, left hand limit should be equal to the right hand limit. Left hand limit of the function is a plus 2. A plus 2 is equal to 1 by 2. Then what is the value of a? A is equal to 1 by 2 minus of 2, that is minus 3 by 2. So C is equal to 1 by 2. A is equal to minus 3 by 2. Okay. What about B? Yes. Shruti, can you tell me what is the value of B? A is equal to 1, C is equal to 1 by 2, A is equal to minus 3 by 2. What is the value of B? In the original question, the question was to find out the value of A, B and C. Now we are able to find the value of A and C. And what about B? B is any real value. B is any real value except 0. Why not 0? If you take B is equal to 0, then the denominator will be 0. If the denominator is 0, then total expression will be undefined. Okay. B can take any real value except 0. Okay. Shruti, did you understand? I hope it is clear to you. So I'll discuss another question. Write down another question. Let f of x is equal to tan of pi by 4 plus x whole raised to the power 1 upon x if x not equal to 0. So if x less than 0. If x less than 0, A, if x equal to 0, then e raised to the power 1 by x plus e raised to the power 2 by x plus e raised to the power 3 by x upon a raised to the power 2 by x plus b e raised to the power 3 by x if x greater than 0 is continuous at x is equal to 0, then find A, B, C. Sorry, not C. Find A and B. Okay. So first the functional value of the function. F of 0 is equal to A. Now calculate the left hand limit of the function LHL, that is limit extending to 0 minus tan of pi by 4 plus x whole raised to the power 1 by x. Okay. When x is approaching to 0 minus, pi by 4 approaches to pi by 4 plus x approaches to pi by 4 from the left hand side. So tan approaches to 1. So this the base function approaches to 1. When x approaches to 0 minus, the power function approaches to minus infinity. So the indeterminate form of this limit is 1 raised to the power infinity. When I was taking a limit class, I have told you if a function limit extending towards a, I'm writing here again, f of x raised to the power g of x, when x approaching to a, if the base function approaches to 1, power function approaches to infinity, that is if the limit takes the form 1 raised to the power infinity, then limit extending towards a, f of x raised to the power g of x equals e raised to the power base function minus 1. E raised to the power limit extending towards a base function minus 1 into power function. Okay. So those who want to note it down, please note. 1 to the power infinity form limit. How to go? Find the limit of the function when it takes the indeterminate form 1 raised to the power infinity, right? If the base function approaches to 1 and the power function approaches to infinity, that is the limit takes the form 1 raised to the power infinity, then that limit will be calculated by using the formula e raised to the power limit extending towards a base function minus 1 into power function. So this is equal, so this limit is equal to e raised to the power limit extending towards 0 minus tan of pi by 4 plus x minus 1. Tan of pi by 4 plus x minus 1 into power function is 1 upon x, right? All of you know what is the formula for tan a plus b? Tan a plus tan b upon 1 minus tan a into tan b. So tan of pi by 4 plus x, I am writing it separately. Tan of pi by 4 plus x. Tan pi by 4, that is 1, plus tan x upon 1 minus tan a. 1 minus tan pi by 4, that is 1, into tan x. So tan pi by 4 plus x is equal to 1 plus tan x upon 1 minus tan x. Tan pi by 4 plus x is equal to 1 plus tan x upon 1 minus tan x. So this limit equals to e raised to the power limit extending towards 0 minus 1 plus tan x upon 1 minus tan x minus 1 into 1 upon x, right? This is equal to e raised to the power limit extending towards 0 minus, here the LCM will be 1 minus tan x, 1 plus tan x minus 1 plus tan x. The numerator will be 2 tan x divided by 1 minus tan x into 1 upon x. Now separate it into two limits. This is equal to e raised to the power limit extending towards 0 minus 2 tan x upon x into 1 upon 1 minus tan x. This is your standard formula, limit extending towards 0, tan x upon x is 1. This is equal to e raised to the power 2 into 1 upon 1 minus 0. This is equal to e raised to the power 2, that is e square. Okay. So value of the function is a, left hand limit is e square. Value of the function is a, left hand limit of the function is e square. Is it clear to you? Did you understand, guys? Quickly note it down. I'll move to the next page. Okay. Then we have to find out the right hand limit. So right hand limit will be calculated at this point of this function. Okay. So RHL will be RHL limit extending towards 0 plus limit extending towards 0 plus e raised to the power 1 by x plus e raised to the power 2 by x plus e raised to the power 3 by x upon a e raised to the power 2 by x plus b e raised to the power 3 by x. Okay. When I was taking your limit class, already I have told you dominating factor. Okay. Here the dominating factor is e raised to the power 3 by x. Now divide both numerator and denominator by e raised to the power 3 by x. Okay. Divide NR means numerator, and DR means denominator, by e raised to the power 3x. Okay, this is the dominating factor. This is equal to limit extending towards 0 plus e raised to the power 1 by x upon e raised to the power 3 by x is equal to e raised to the power minus 2 by x. Oh, sorry, 3x, no, 3 by x. E raised to the power minus 2 by x plus e raised to the power minus 1 by x plus 1 upon a e raised to the power minus 1 by x plus b. Okay. When x approaching to 0, e raised to the power minus 1 by x approaches to 0 because e raised to the power minus infinity. E raised to the power minus 2 by x also approaching to 0. Okay. So this limit will be 0 plus 1 upon 0 plus b, that is 1 by b. Clear? This is equal to 1 by b. Left hand limit, what is the limit? Left hand limit is square. Functional value a is equal to e square since the function is continuous. So 1 by b is equal to e square. So b is equal to 1 by e square or e to the power minus 2. Okay. A is equal to e to the power 2, b is equal to e to the power minus 2. So guys, your first session is over. Second session, I'll start exactly at 9:15. So I hope the students, those who are present in the first session, all of you should attend the second session. Okay. Nasreen, is it clear? Jagdish, what is your aspiration? You are preparing for JEE or NEET? Jagdish, NEET.